Hello guys, how are you? Am I visible? Please write in the chat. We'll start at 8 p.m. Start. So if you have your friends, you can also send them the link and ask them to join you. So anyone, this is the first day of a boot camp, and anyone who's completing the boot camp will give them certificates, and they will give them resources as well to prepare for like companies and all, right? How you doing, guys? You can write in the chat. I'll start in 1 or 2 minutes. It's 8 p.m. already. Hello guys, how are you? Please write in the chat. Shall I go? Shall I continue? Hi alone queen. Okay guys, then I will start. So as you know, this bootcamp is hosted by Skill Pulse, and today is the first day of our bootcamp. So anyone who is completing the 5 days bootcamp will get to learn about data structures and algorithms, what part they play in getting us jobs in the IT companies. So yeah, I recommend you to find a very quiet place and put your headphones on and listen carefully, right? And yeah, so let's continue. So today's topic, as you all know, this is about introduction to data structures and algorithms, right? So before that, I want to know why you need to learn data structures and algorithms, right? So first of all, data structures and algorithms forms a building block of coding, right? So you need to know data structure and algorithm if you want to get into any kind of job, right? So let's do an experiment here. Let me go to the chat GPT. Let me open a new chat. So let me write, what jobs can you get when you learn data structures and algorithms? So let me know if I'm audible or not. Am I clear? You can write in the chat. So yeah. So what does ChatGPT tell us? Let's see. So first of all, it is telling us learning data structure and algorithms opens up wide range of job opportunities in the field of computer science and software development. These skills are fundamental to solving complex problems and blah blah blah. the part we're interested in is that software engineer developer. So you can be a software engineer or software developer if you learned data structure and algorithms. You can get into data scientist as well. You can be a machine learning engineer. You can be an algorithm developer, backend developer, systems engineer, game developer if you like to develop game. System engineer's role is very common in Infosys if you are aware. Database administrator, quality assurance engineer, QA engineers are also very uncommon roles that are opening up, and quite easy to get them a seat if you are not from a prestigious college. Cybersecurity analyst, research scientist, competitive programmer. So like, and this is a very short list actually, and there are many roles, right? So which you can get into after learning data structure and algorithms. So let me so what should be your dream, like what should you target to get into in your career, right? So what I can suggest there, okay, you can target for the top IT product companies. So service companies are like Wipro, Infosys, TCS, Capgemini and all that. And what are the product companies? So this is the list. So these are the top product companies that you can dream of. You, even if you cannot get in initially as a fresher, you can get into eventually if you learn data structure and algorithms, because most of them only ask data structure and algorithms, believe me. And they may be of varying difficulty, but mostly they are going to ask you about data structure and algorithms. Apart from them, there are related to HR questions and design problems. But most of them, like Amazon, if you know, 2 rounds of DSA. Microsoft, if you ask me, they ask also like 2 rounds of DSA, one related to machine coding. Then there is Flipkart, Amazon, Cred, Samsung, Paytm, PhonePe, and they will pay you like for a fresher. If you ask me, they pay you like 15 to 20 LP of salaries. So that's how they're going to pay you. So, and it's not like you need to be from an IIT and very prestigious college to get into that. It's not like that. I have seen my friends who are from RV College of Engineering and what do you call Suburban Institute of Technology. Then there are many colleges from South only, like where they who have managed to get into these top companies. And being in the South, companies usually visit these regions very often. So you have a fair chance to get into these companies, but you need to have that skill. Otherwise, you cannot crack it, right? So am I clear till now? You can write in the chat. So let's continue. So what is data structure? What is the meaning of data structure? So do anyone know what is data structure? You can write in the chat. What do you mean by data? And what do you mean by structure? So let me break down, right? So data is like information. It can be any information, right? And what is structure? Structure is like a frame. And this data structure completely comes together to be called as data structure. So it's a frame holding a data. So that's what data structure is. So if you in the physical world, you can think of like a box can be a data structure. Any object can be a data structure because they hold some kind of data. A bottle can be a data structure. Anything can be a data structure in the physical world. But I will now model it properly because only some of the data structures are useful to us. So first of all is an array. Like do you know what array is? Like let me give you a first example. Like first read this. In an array, elements are stored at contiguous memory locations and can be accessed using their index. So forget about it. You can see this egg tray, right? So this is an array because every element is placed next to each other. If you're standing at 2, you can just move here to get to this element. When I say element, it can be an object or any piece of information. So that's what I'm calling as an element. So this is an array. So so if you have any examples, you can put in the chat, like what comes to your mind when I say to an array. When I say an array, another can be your like ice plate, ice tray, which is present in your fridge, right? um, yeah, raw set of information, correct. I will be checking the chat. You can write examples of arrays. Then second is that is another important data structure is stack, right? What is a stack? So stack, you can see here which out of this you think is in stack, right? This one, because one is placed over another. And stack operates in a LIFO mechanism. What is LIFO? LIFO, do you know? You can write in the chat. It means last in first out. And what do you mean by last in first out? So the elements that goes last would be the first to come out. So for this stack, you can see if I want to get to this orange bowl, what I have to do, I have to remove this first, right? Then only I can get to this red bowl, otherwise I can't. And red one is the last element that goes into a stack, but it is the first one to comes out if you want to pop this stack, means if I want to empty this stack, right? So that is the stack. Now what about queue, right? So queue, you have gone to an hospital, you have gone to a restaurant, like dining takeout place, where you have to wait, where you have to queue, right? Queue in a line. So it's like the opposite of a stack. So it's like it follows the FIFO mechanism. Like when you heard these jargons now, these are very common in computer science also. You will get to learn this in future, like you will heard them often. So let's learn them now. So FIFO is basically first in first out. So what it meant by that, ki when there's a queue, the first element that goes in would be the first to come out, right? So in a queue, right? So when people like get arranged in a queue, the first person would be the first person going in that queue, then the second person would be the next one that's going to be processed, right? So it works like that. So you can give me queue examples in the chat. One would be like when you go to when you're patient and you're going to a doctor's appointment, so you can see a queue there. Another can be you're waiting in a restaurant. Another can be you're waiting for your mark sheets to be shown, waiting in a line. So yeah, so that's a queue. Any doubts you can write in the chat. Now the fourth important data structure is the map, right? So what is a map? So map is basically it's a data structure that holds key value pairs, right? So where each key is associated with a value. You can think of it as a locker room. So you have a locker room. So you can see this picture. This is a locker room. If you have the key to the 14, you can view what's inside, right? If you know the key, you can easily find out the value. And value can be anything. It can be a number, it can be a text, it can be a piece of cloth, it can be anything. So that's how these are the four important data structures I wanted to talk about. So yeah, so let's move ahead. So before you proceed, I want to tell you this is the first day of the 5 days bootcamp. So next one being going to hell tomorrow. So as part of the bootcamp, I require you to mark the attendance, right? And whoever is has attended the 5 bootcamps will be giving them free certificates, and will giving them resources as well. So this is the link. Go ahead and mark your attendance here. Yeah, arrays, fruits. Yeah, stack is first in last out. Yeah, correct. Yeah. So yeah. So mark your attendance. Okay, let me show you how to mark your attendance. Otherwise, you may be confused. Okay, yeah, fill your name here, fill your email here, fill your phone number here, WhatsApp number that you use. You can make the same if you use the same number. College name. If you are a graduated student, then you don't have to write your college name, and put your year here, and put your branch like electronics, computer science, whatever it is. Yeah, that's how you are going to fill it. And yeah, let me continue. So before that, let me tell you about me. So So who am I? Do you know me? Like, you can write in the chat. Otherwise, I'm going to give you an introduction. So this is my LinkedIn profile, right? So if you are not aware of LinkedIn, what LinkedIn is, so I think I'm going to tell you from the start, like, this is very important. LinkedIn is very important to grow as a professional, and it's very important to make your online presence in the corporate world, right? So this is so it's like a social media only, like Facebook and Instagram, but it's for serious things only, like related to jobs, related to internships. So if you're searching for jobs and internships, so LinkedIn is the place where you should be, right? So this is the LinkedIn. You can see my headline. So this is my college experience. I am graduated 21 from IIT ISM Dhanbad. I have been working as an engineer in Uran.com. It's a B2B company, if you're aware of it. It's like an Amazon for businesses. Now I'm working as a backend engineer at Cred. So if you're not aware of Cred, maybe you don't have a credit card. If you have a credit card, then Cred is the app you should download. And you can, and Cred has online presence also in YouTube. You can also search that. It's a very Gen Z kind of app. You can look into that, right? Then most important part of it, of a LinkedIn profile, is your skills. So you can write your skills like that, and people can search you based on your skills, and they will DM you about the offerings, internships and jobs they have. So, and you can list down your projects here, and projects you can write your GitHub links here. So the link is not working. So yeah, so that's LinkedIn. I will suggest you guys ki I am not suggesting, I am asking you guys, go to LinkedIn and make your account as soon as possible. And tomorrow I'm also going to give you a task around LinkedIn if you have created your account. So yeah, and this is the place like where you can search your jobs. You can search for jobs based on your titles. You can search for internships as well. Yeah, so that's how you can use LinkedIn. Okay, so let me continue. So that's about me, and yeah, so do you have any doubts? You can ask me. Sir, how can I get certificate? You have to fill the form. For 5 days you have to fill the form. You have to be regular, then we'll be giving you certificates and resources to prepare, right? And now to our first data structure, it's array, right? So what's an array? Like I mentioned, it's like continuous memory spaces arranged continuously placed together, and this is the boring stuff, like how to declare an array, memory allocation and all these things. So before that, like do you know about memory? Like there are different type of data types. Data types can be character, integer, float, string, and there's an integer data type which takes values like from 1 2 3 4 all numeric values, or you can take it to be a mathematical integer only, like it can goes in the negative direction also, -1 -2 -3 and 0 included. So one integer takes 4 bytes of memory. So do you know what a byte mean? Have you heard about megabytes or kilobytes or gigabytes? Can you tell me like how many bytes makes 1 kilobyte, and how many kilobytes makes 1 megabyte, and how many megabytes makes 1 gigabyte? Can you write in the chat? Can you write like how many bytes are 1 kilobytes? There's a little lag here. So we'll go to this Lead Code Playground. You can search for it. It's an online IDE, right? So you can write code here basically. So let me open a new playground. So I want to see some responses. Yeah, 1024 bytes is 1 kilobytes. Yeah, correct. Correct. You guys know well. So I've gone to this lead code playground, and now I'm going to include the headers. So this is a header file. It helps us use all the STL. What is STL? There are some predefined what do you call algorithms and data structures, like for sort and all these things. It's available in this file. So when I include this, I will be able to use it. And then there is a namespace, which means days all files included in the namespace, because there can be same name in different kind of same kind of object in different namespace also. So we put this using namespace standard only. So this too you have to memorize. You can deep dive into by doing your own research why you use them, right? So first of all, and this is the main function. This always has a return type of int, even if you don't return from this function. This is like your entry point to your code, right? So let me define an array here. So let me define a variable here. So I have written int x equal to 3. So x is a variable which takes value 3, and this is how I'm printing it. Cout means I'm printing out using these are just denotes what I'm printing out. What does endl means? Endl means you can also skip this. This means I'm printing a line at the end, means I'm hitting enter at the end, right? So I can, if I print it like this, the output will be 3 because there is no gap in between, right? I can do it like this. So this will place a space between, and if I write it like this, endl and x, it will print it like this, because this endl means I'm going to a new line, right? So let me show you how to declare an array. Will need an n here. Okay, now I'm going to explain you what I have done here. So first of all, I have declared an array here. So int arr, int is the data type, arr is your array name, and this is the basically size of your array, right? Now if I remove this, then also it is going to be, the output would be the same only. Now what I have done, I have declared all the elements that are in the array, and what I have done, then I have written int and size of array. So size of array will give me how much? Do you know? It will give me 16 bytes, and size of int is 4 bytes, and this comes around to be 4. Now another important thing here, like I have written it here, an array starts with the index 0. So it always starts with the index 0, that you have to remember. So what I have done, I have written this for loop, and for loop, this is your initial condition, this is your it's your initial declaration, this is your condition that's going to be checked, and this is your increment. So what's going to be done here? So first I is 0, so 0 and array of 0 is 3. Two are going to be printed here. Then my I is going to be incremented, means I was 0, now it has become 1, and again I am going to check if I is less than n or not. For me n is 4. And what about I know I has become 1. So is 1 less than 4? Yes. Then we'll be printing 1 and array of 1. Array of 1 is 5. Then again we have incremented I to 2. Again we are checking is less than 4 or not. Yes, it is. We'll printing 2 and the element at index 2. The indexes will be looking like this: 0, 1, 2 and 3. And finally we have incremented to 3 and checking if fits and printing the value of this. Then we have incremented it to 4, and at this point this is not valid and this will be exiting our case. Now what we can check here, we can like write it equal to also, which means now it's less than equal to 1, means it will go till 5. So it's like writing your mathematical notation only, but it's giving me index 4 is out of bounds, right? So again, what do you think? What if I try to print array of -1? What it can give me? You can write in the chat. So that's how it's going to be. If it's going out of bounds, it's giving me an out of bounds error. So for -1 also you can try that. It's going to give the same only. So that's what was an array. Any doubts you can write in the chat. Okay. Okay, let's move ahead. So that was your data structures. I have given you a glimpse of what array is. Stack and queue is going to be covered later in the bootcamp, so don't worry about that. Now this is another part of our topic, is like data structures and algorithms. So what is an algorithm? So algorithm is basically a set of defined rules which helps us achieve a goal, right? You can simply put it like that, but yeah, let's go ahead. So before that, there are two things you need to know, because these help you design and analyze algorithms, right? So first is flowchart, right? So first is flowchart. Let me draw you a flowchart and tell you how it's drawn. I'm guessing you might have heard about flowchart. You can let me know in the chat. So I want you to write an algorithm. One sec. Yeah. Find given a number, print even or odd, right? So this is my problem. So I'm given a number and I have to print even or odd. So I have to design an algorithm for that. So what I can do, let me write steps first. So my algorithm, how it will look like, right? So first of all, we'll take the input of a number, input number. What we'll do then, well again, let me call this number n. We'll check if n is divisible by 2. If divisible, then print even, right? And if not, then print odd, right? And before that there will be start and end also. So let's write the algorithm. So first of all, this is the algorithm start, and there would be another one that is calling your end. Now we have to reach here from here. So this is a shape which tells you input. So I am saying input n. Then again it will move to a decision box. This diamond is a decision box. Now to check it's divisible by 2 or not, we have to write like this. Okay, let me write it single equal to only. So what this percent means in computer science, it's in coding, it means we're taking a modulo. So when I say I'm taking 5 modulo 2, it is giving me 1 because it's the remainder, because when I divide 5 with 2, it's giving me that remainder. When I divide 4 with 2, it will give me remainder 0, right? So what I'm going to check here, I'm checking if n divided by 2, what's the remainder when n is divided by 2. It's giving me 0 or not. There can be two cases. It can give you let me write like this, even and odd. These are input and output boxes, sorry, odd. So let me draw the array. First we are at the start, then we'll move to the decision box. From the decision box we'll move here, and this is the yes case, right? And again we'll move here to here. This is the no case. What I mean by yes or no, I will give you a demo. I will give you a dry run. So this is how it's going to look like. So let's say we have inputted n equal to 4, right? We are checking if 4 divided by 2 is equal to 0 or not. Yeah, it's going to be 0. Then this is the yes. So we'll go to the yes part, yes flow, and this even number will be printed. So this is how you move. Let me change the color. So this is how we are going to move. So this is the flow. That's why it's called a flow chart. N equal to 4, right? And what about now 5? So n is now 5. So what about that case? One sec. So n is equal to 5. Let me change the color. N is equal to 5. In that case 5% 2 is equal to 1, which is not equal to 0, right? Which is not equal to 0. So in this case it will move like this. Right? So this is a flow chart. So let me know if you have any doubt. Okay, so let's move to the another part, that is your time complexity. So what is the time complexity, right? So so every statement in code, right, you can give them a time complexity they can have, like how much time they are going to take, right? So you can think of it like this is a declaration statement, or like when you do a sum, like this calculation only, we write them as big O of notation, and we write them as an input of n. So n, if n is your input, how is it going to, what mathematical operation you have to do with n, so it represents the time complexity. So in terms of input, regardless of my array size, it's always going to be constant only, because it's just a simple calculation, dividing two numbers. Same can be addition, same can be multiplication. It's going to get only O of one time only, constant time only. Even if we are going to add another number, simple mathematical operations are going to all mathematical operations, you can say, between numbers, it's giving us only O1 of complexity. Can you tell me what's the complexity of this statement? And I want your complexity for this also, for this for loop, for this statement, what will be the complexity, and for this outer for loop, what will be the complexity? Can you write in the chat? So let me tell you, like it will be big O of 1 only, but this is repeated now n times. So n times big O of 1, but this is not how we write. We write it like this, O of n, because this is O1 statement, because we are printing a number, but it repeated n times, so it's going to be big O of n only. Then another can be your multiple for loops. They can be nested for loops like that. So in this case, if this is O of n, then there is another for loop above it. So in that case it will be n into O of n. So this time it becomes O of n into n, or you can also write it like O of n square, right? So this is how complexities are defined. There are few other complexities as well which you can get to know while learning the algorithms. So O1 is the least taking time. It takes very minimum time. Then there is O of log n, right? So when you take log of n, it takes a slight bit time, but it's still it's less than O of n, but O of n is greater than O of log of n. When I say it's n square, it's parabolic. Like you have I think you have learned all of this in your high school mathematics, right? Then there is the exponential, which is 2 to the power n, or any number raised to the power n is your exponential complexity. And this is how they looks like, from most taking time to the least taking time. Now let me tell you about the sorting algorithms. It's one of the very popular type of algorithms, and it's good at start to know. So like you are given books, right? You are on a table. There are books arranged on your tables, but they are all random. Like how you are going to sort them, right? So how do you sort them actually? So you can pick one book, and the name starts with like S, right? You will thinking S comes later in your dictionary, so you will put it on your right. Then again you will take another book. Then you can see the name starting with A, so you will put it at the first. That's how you are picking a book and checking the name and comparing where it should be placed, right? You have to arrange them in a line, then that's how you are going to place them. But this technique can take you more time, because it's a very random technique, because you are pulling out a book and checking its name and putting it somewhere, but it may not be efficient. Suppose you have taken a book, it's start with S, but you have kept it at the last, and it might be cases ki all your books name starts with SYZ only. It shouldn't be put in the last, right? It should be placed somewhere at the start. This is not like an optimized algorithm, right? So there are some popular algorithms which we can use to teach the computer how to do a sort, because you cannot say like you cannot unless you give the computer a proper way, it cannot execute on its own, right? So these are some of the popular algorithms for sorting: bubble sort, selection sort, insertion sort, merge sort, quick sort, heap sort, counting sort, and radix sort, right? So the one we're going to talk about is insertion sort. Like, do anyone know what is an insertion sort? You can write in the chat. Do you know what insertion sort? Why is it called insertion? So let's take the dictionary example only, right? It will be easier that way. Okay, let me take this one. This is a vertical array, don't get confused, right? We have dog. Let's say these are all text which we have to arrange. Okay, it's like hitting a dot. We have cat, we have eagle, we have elephant, and what else? Give me some names. We have kiwi, right? Okay, so what we'll do first, how insertion sort works, let me tell you, right? It can be anywhere, randomly placed, right, one after another, and we have to arrange them. So what we can do, we can basically take the first element and put it here. Now we have gone to the next element, right? Now what we can do, we can put, what we'll do before putting it here, we'll be comparing it with the previous elements. Do dog comes after k, do d comes after k, sorry, do k comes after d, yes it is, so we'll place it here only. Now again Now it's the eagle turn. Now eagle will compare with kiwi, right? So we can compare with kiwi and we'll check if k comes after e. Yes, it is. So what we'll do, we'll say kiwi will go here and we'll swap their places. First of all, let me tell you like this: kiwi was here, eagle was here. We have to do a comparison and check should eagle be moved above. And yes, it's the case because e comes before k, right? So kiwi will be down here and eagle will move up. Again we'll compare d and e. So e comes after d, so it's well and good, so there will be no movements further. Now cat comes. Now cat will compare c and k. So again we'll find ki k should comes after cat, so cat will be here. And again we'll compare c and e, right? We know c comes before e, right? So in this case we'll move again cat up. Then again we'll compare cat and dog. Cat will move up and dog will be here only. So are you following like how we are doing it? So again we have elephant. We put elephant here. We'll try comparing it with kiwi. Yes, e comes before k, so it should move up. It will swap its place with elephant. Now again eagle comes. Now you can see both are e. How we are going to compare? If these both are equal, we're going to compare their second character, right? Second letter you can say. So we can see a is less than l. So I don't think it will. It's greater than eagle only. So this is my final sorted array. This is how it's going to be look like. So why is it called insertion? You can see these are all random beforehand, but we are keeping on swapping them till they reach their final position. So it's same as saying ki we are inserting them at the correct position only. We can skip the swaps and we'll say let's say for this example we can say we are inserting elephant here only at this index 3 only. For that we need to move this, right? So that's how insertion sort is going to look like. If you have any doubts, let me know in the chat. Did you understand? Can you write in the chat, did you understand that? Did you follow what I told you? Otherwise I can repeat myself, not a problem. Okay, let's get into code. So before we are writing here only code here only, but let's delete this and write this code in a function. So what's a function? So function can be, there are various return types. Do you know what are the return types? Can you write them down? So these are void, int, float, and all the data types including void. So let me name it down as a insertion sort algorithm. Right, now what we can do, we can basically write insertion sort here and we'll passing here an array. And we'll be passing here the size of the array, right? So let's write a so let's first iterate the array and print all these elements, right? For now let's make it interesting. We'll take the same example as before. We'll take string array and we'll take the elements name, dog, we have cat, we have what do we have, elephant, we have eagle, and we have kiwi. So let me name it more meaningful, because it's always good to name your data structures meaningful. Now I will be doing insertion sort. In the insertion sort, I'll be passing on animals, and I need the size here. So size will be size of animals and size of int, and we'll be passing here the size as well. Now this is the insertion sort algorithm. What we can do, we'll be writing here int. First of all, let's print the elements, right? Now you can see I have written it as a string. So what is a string? String is basically words, you can say. So let me okay, there's some error. Stack buffer overflow. Memory access, size int, partially addressable is an hyper. There's some error. Let's try to debug it together. It's saying stack buffer overflow and address. Okay, I have written insertion sort string array, and I have written the size. Is it happening or because of this for loop? So one of the okay, so it's working now. So let me try to print it. So one of the rules of debugging is that you try to, okay, this is the mistake here we have done, right? This is the mistake we have done. Have you realized it? So size of animals, it's going to occupy, we don't know this size because string doesn't occupy a fixed amount of length, right? This the size of a string is the amount of characters it has. So for elephant it's 7, for eagle is 6, for kiwi is 4. So it's not going to work like that, right? So we need to know the size here. So our size is 5. So we have to write it like this, 5 here only. 1 2 3 4 5. Now we can see it's coming to be 5, and now this is going to work. Right? Now it's printing them correctly. Now what I want to do is that I want to sort them, right? Like I mentioned. So first of all, I have to traverse them, right? Int I equal to 0, I is less than n plus plus. So what is this step? We are basically considering each of the elements now, right? So what we'll do, we'll again do a comparison with the previous element. So we can write it like int I is equal to I minus 1 till j is greater than equal to this, and we'll write j minus minus. So what am I doing here, right? So let's take the same example only. So we have cat, we have dog, we have elephant, we have let me write it like this, eagle, and what do we have? Kiwi, right? And let me take in the same order as this only, right? Dog, cat, elephant, eagle, kiwi. Is it okay? Dog, cat, elephant, eagle, and kiwi. And let's assign index each one of them. This is 0, this is 1, this is 2, this is 3, and this is 4, right? Now what you can see here, now I have declared an index I. So first index is I will take an index that is previous to this, right? And we'll compare key if swap is required. For I can see dog is okay here only. Now we'll move I to this place. because z will be initialized here only, and there's no elements here. So in this case I will initialize j here and compare if I and j can be swapped. So we'll do the same comparison ki if cat is less than dog, yes it is, we'll swap them and we'll move j further, right? Again there is no element, our loop will end here. Then again we'll increment I and we'll initialize j from here, right? J is equal to I minus 1, right? Again we'll compare d and e. So it's again well and good because e comes after d. So again at this point we'll block, because there is no point incrementing the j and comparing c and e, because this part is already sorted, right? This part is already sorted. So again we'll move j here and put I here. We'll move I here first and then we'll initialize j is equal to I minus 1. We'll compare elephant and eagle. We can see elephant and eagle. Eagle comes before it and elephant comes here. So we'll do the swap and move j ahead, right? Again we'll compare d and eagle, and this actually we're comparing this to the next element only. We'll compare dog and eagle. Are they going is swap required? No swap required, right? So again we'll move I, and that's how it's going to look like. Let's take another example. Let's take, it was like say ape, right? So it will be more clear then. So we have I here and we have ape here. Now we'll compare elephant and ape. So we can see a comes before elephant, so we'll swap them and move j to the left. So j is now here. We'll again compare j with j plus 1. We'll see ape comes before that, so eagle will be here and ape will go here, and this process will continue. This process will continue till ape reaches the very start. Right. So let me write the code here. So what we have done here, we have initialized j equal to I minus 1, and we are continuing till j is greater than equal to 0, and we are incrementing j each time. So now if array of j it should be like this. If array if this array of j plus 1 element is less than array of j, we'll be swapping them. We'll be swapping them, right? Now okay, now let print this again. We'll be printing our array again. Before that let me write like this: after sort. We can also put handle here. Right, after sort, and let me put another handle here. Yeah, this was the array before sort, and this is after sort. You can see this is all sorted. Let me write ape here and run this again. You can see ape is here now at the very start, and this is how this insertion sort is going to work like. But do you think there can be an optimization here? Can you optimize this code? Can you optimize this code? You can see here there is something we can do here to optimize this code. Now let me tell you what the optimization can be. So right here, like suppose say cat and dog is here, and we are at eagle, and our I is at eagle, and we have initialized j here only. Now we have compared dog and eagle. So dog comes before eagle, right? So this is a valid case, but is there any point comparing j? Is there any point comparing now cat and dog? Is there any point comparing them? What do you think? Because we are standing at I. So what I have said ki this part has already been sorted. So is there any point comparing them again if this doesn't if this doesn't hold true, if eagle was not here, so is there any point comparing? No, it's not, right? Because this part is already sorted. If the case was like if eagle has come here, a new entry has come here, then only it makes sense to compare on the go j on the left and do the comparisons, right? So in this case, this is our final state only. Means for this is our final state only. We don't need to do any comparisons here, right? What you can do here, we just have to add something here, that is else break. So we are getting the same results only, but now our count has reduced. So let me give you an example like how you can check the count. So I'm incrementing the counter every time we are in this for loop is running, right? So let me remove this and let me print the count. So what you're again, okay, it's counter and I'm writing is a count. Clear? Okay, so count is 10. Now if I add this code, right, I can write it like cout. Sorry, I have to write it here, break. So what this break does, it says ki don't continue this for loop, break out of this for loop and go to the outer for loop only. So now we can see our count. So now you can see the count has reduced to 6. So we have saved 4 comparisons, right? So we have saved our time in a way. Even though the algorithm output is same, we have saved some time. So that's how it's going to work. Now let's come to the time complexity. Can you write in the chat what would be the time complexity? Can you write the time complexity? Again, who are attending late, this is the attendance sheet. Just fill it out. It's for you to get certificates and all. So fill out the attendance form. So can you tell me the time complexity for this? I have already shown you what's the time complexity when there's two for loops. So let's do it together. So for the first one, what do you think? It will be O of n, because there is single for loop. For this is a swap and this is a if statement. All of them are going to take O of 1 only. It's going to take off O of 1 only, even it's a conditional statement. Now what about this? This O of 1 is taking, like you can see, it's taking j times, right? And j is our variable. But what the max value that j can go? It can go up to n, right? So we'll take that only, because this is the worst time complexity. So we take how much j can go. It's the O of n only. So n is basically our input, right? And again, this is again 2 for loops. It's again n into O of n. So this here becomes O of n square. And out of comparisons, when you compare O of n and this is also your O of n, so the time complexity is max of all of this. So what do you think max of all of this? This na. So this is your so this is the case. So O of n square will be your time complexity, right? So time complexity of this algorithm is O of n square. Did you get it, or shall I repeat myself? So yeah, so now we are done with insertion sort. Now we'll continue with the counting sort, right? Let me explain you a bit what is counting sort, right? So say we have list of numbers 1 2 3 4 5 5 6 6. I have written them all, like let me write in a random way. Say we have 3 2 3, then we have 1, then we have 4, then we have 5, then we have 1. So what do we do in a counting sort, right? So we'll be putting them in buckets. So what do you mean by bucket? So we'll make buckets first. So these are the buckets, right? And each bucket will hold a certain type of value. 1, 2, 3, and 4, and 5, 8. So each one of this will hold a certain type of value. First will be at standing here only. Here we can see it's a 3. We'll increment it by 1. Bucket value will be 1. Initially all of these will be initialized to 0 only. You can assume that. Now we have gone to 2. Now we have I have to use this. Okay, not this one. Okay, now we have gone to 2, right? Now we have gone to 2. Now will be increasing 1 this. Now we have gone to 3. Will be increasing this to 2, incrementing 1 again. Then again we'll go on to 1. Then we'll be incrementing this. Then at 4, right? So at 4 we'll be incrementing this by 1. We are at 5, we're incrementing this by 1, and we are at 1, we'll be incrementing this by 2. Then what we have to do, we have to iterate this array from this left, and put how many times the number has occurred, right? 1 has occurred 2 times, so I will write 2 times once here. Then I will move ahead. I will put 1 times 2 here. I will put 2 times 3 here. I will put 1 times 4 here, and I will put 1 times 5 here. So this is my final sorted array. And how you are going to make this bucket? You can take another array, right? You can take another array. Okay, let me take index array, so it will be easy. You can take another array like this. This is my count array, right? Where you can keep the counts. For 1 it is 1, for 2 it is 2, for 1 it is 2, for 2 it is 1, this one. Then for 3 it is 2, and for 1 it is, for 4 it is 1, and for 5 it is 1. And from this count array you can iterate it and put the elements from the left to right, and this would be your final sorted output. So I'm not going to write code for this. Users have to only try writing this code. You can go to Lead Code Playground and try writing the code. And yeah, that's pretty much it. Like, if you have any doubts, you can ask. And again, do come tomorrow, because I will be sharing some awesome resources with you, like some top DSA questions you can prepare for yourself. And yeah, that's it for this webinar. Do you have any doubts? You can write in the chat. I'm waiting for 1 or 2 minutes. Write in the chat, did you enjoy this session? Let me know. Yes, you can ask if you have any doubts. Okay, cool. I think there are no doubts. Yeah, so good night, guys. Sleep tight, and do come tomorrow. We'll be learning an important algorithm tomorrow, and I will be giving you an activity on LinkedIn, right? So do come tomorrow. So yeah, nice to have you guys. Yeah, take care. Bye.